Of all the intimidating factors of chemistry, the M word dominates. Anybody mentions mathematics, the students want to hide under their desks. But secondarily to the mathematics is the oxidation reduction. In today's presentation, you will see my take on oxidation reduction, which seems to work reasonably well. Now, oxidation reduction has to start with definitions. Oxidized means losing electrons. Okay, that's easily grasped. Reduced means gaining electrons. Well, that's opposite the way you're taught. When you reduce something, you lose something. In this instance, you gain something. Further, more specifically, oxidized loses electrons, but is the reducing agent, and reducing gains electrons and is the oxidizing agent. So how in the heck does that apply? Well, let's go through a simple example. Now, virtually the most efficient of all possible fuels is methane, CH4. Now, when you burn it, it produces carbon dioxide and water vapor. Perfect fuel. Now, what would be better? Hydrogen. But if you're going to fractionally separate water into hydrogen gas, it's going to take more energy than it produces. You can't get it out of the air because it's 0.0005% of the atmosphere. So getting it out is extraordinarily difficult. You'd have to freeze a huge amount of atmospheric gas and fractionally distillate it that way. And again, it would be more energy used to produce a very small quantity. So outside of hydrogen, the best is methane. What we have here is methane being ignited in a gaseous atmosphere of oxygen, producing carbon dioxide and water vapor. Now, methane is comprised of carbon and hydrogen. Now, hydrogen can only have one charge, and that's a +1 in a reaction. So in this case, hydrogen is +4, but carbon is a -4, which is pretty unusual. On the other side of the equation, carbon suddenly becomes a +4. So your movement of electrons is from -4, you lose 4 electrons there, to a +4, and you lose 4 more electrons because you start from 0. So you lose 8 electrons as you move. It is definitely being oxidized and is by definition the reducing agent. Now you got to come up with 8 electrons on the other component. So oxygen goes from 0, which is where it goes to start, to a -2 in the carbon dioxide, and there's 2 of them, so there's 4 electrons accounted for. And over on the other side of the fence, you have water, which has oxygen as a -2, but there's only 1 of them, so now you only have 6 electrons. In order to make that work, again, this is reduced because it's gaining electrons. So in order to make this happen, you must balance the chemical equation itself. Note your carbons are 1,1 on either side. Hydrogens, however, 4 hydrogens in the methane and only 2 in the hydrogen. So to balance that, we simply put a 2 in front. As I've schooled you earlier, is the, looks like a 1. Schooled you earlier, that's the easiest way to balance equations. But now we have a quandary. We've got 2 oxygens on the left side, but we've got 2 times 2. 2 is 2 plus the 2 from the carbon dioxide gives you 4, and only 2 on the left side. So Back to the old, put 2 in front. Made a better 2 that time, it's easier to see. Now, this is, in fact, reduced and is the oxidizing agent. Reduced because it's gaining electrons. It goes from 0, the starting point, the lowest possible, all the way up to account for 8 electrons. You got 4 from the carbon dioxide and 4 from the water oxygen. And that gives you 8 electrons oxidized, 8 electrons reduced. Thus the oxidation reduction equation. Now I'm going to hit this from a bunch of different perspectives, but I'll use this equation again from a slightly different viewpoint. And hopefully it helps you understand.